So welcome to another session on robots. So today we are going to look at the classification of robots. And robots are generally classified into, we can talk of three ways by which robots are classified. So we can mention the three. For the first one is standard classification. We talk of the standard classification. The second one, we can talk about the broad classification. And the third one, we can talk about general classification. General classification. So those are the three broad ways by which the robots are classified. So we are going to look at each way of classification, and we are going to start by looking at the first one. That is what we refer to as standard classification. So when we talk about standard classification, for the standard classification, there are two standard classifications that we usually have. The first one is what we refer to as the mechanical configuration based. So we can talk of mechanical configuration based, and then the other one is what we refer to as the control method based. Talk of control method based. So we are going to look at the first one under standard classification, which is what we refer to as the mechanical configuration based. So when you talk about the mechanical configuration based, this one is usually based on the mechanical configuration, and it considers the various joints and links that compose, or rather comprising, the physical structure of the robot and the relationship with each other. So in this case, we are looking at the robot as, we look at it in terms of the structure, that is the kinematic chain. So that is what we refer to as the mechanical configuration based. When we talk about the control method based, the control method based is simply categorized considering the type of technique that is implemented in order to control a robot. And under this, we can also have two. Under control based, we can also have two, and that is what we call the non-servo method. We have what we call non-servo method, and also we have what we call the servo controlled or servo method, servo controlled method, servo controlled method. So when you talk of the non-servo method, this one is usually used in cases of limit sequence robots, endpoint robots, and also we can also talk about pick and place robots that are majorly used in setting up machines. So this one is the simplest. They don't need any form of control. There is no need. There is no servo. That the servo whereby maybe there is the corrective mechanism of the error, and therefore it is majorly based on setting up a machine or just a machine setup. Then when you talk about the servo controlled, then the servo controlled is continuous. This is a type of robot that is continuously monitored for feedback to be given to the control system, and they are associated, all these control mechanisms are always associated with each joints. They are associated with the joints of the robot. So in this case, this one, just as the name suggests, it uses the servo mechanism whereby all the time it will be checked if there is a deviation between the output and also the set point in order to bring about that movement, that small difference that will ensure that the system works. So that is all as far as standard classification is concerned. We can go to the second one, which is now what we refer to as broad classification. Broad classification. So when you talk about the broad classification in this case, we can divide, under broad classification, we can divide them into 3. We can divide them into 3. And that is the first one is what we can refer to as the programmable or reprogrammable. So we can talk of programmable or reprogrammable. Programmable or reprogrammable general purpose robots. General purpose robots. So when you talk about the programmable or reprogrammable general purpose robots, then we are simply talking about the robots that operate fully by some sort of programmed data control. And in this case, these robots are always taught beforehand on how to perform as a given necessary action, and this one can be as a result of by using what we can use what we call the teach mode, or we can talk of the teach pendant that will always be used in order to guide the robot on how it is going to carry out a given task or the sequence that is going to use to carry out a certain task. So in this case, a program is given to the robot, and then the robot will then do as it is programmed. And maybe we'll also talk about how this programming will be done when we'll be talking about programming robots. Again, we can also say that when we talk about the program, this one is whereby the robot is taught. We can always teach the robot on how it is going to carry out a certain task. Then afterwards, the robot will take over and then execute the operation. And this one can be done repetitively. And this one can be general purpose robots that can be used in order to carry out jobs like welding, painting. You can also talk about assembly of components for mass manufacture, loading or unloading jobs. And this one can be into or from the machine tools. And in most cases, these ones are useful for all structure operations. So you can use it for all structure operations. You can also talk of things like mechanical, the material handling. That one can also be very, very important. So when you talk about the programmable, then these ones are just the robots that can just be, a program will be given to them, and then they use that specific program in order to carry out certain tasks. The second one, under broad classification, we can talk about what we call the teleoperated man. We can talk about teleoperated, operated. Or we can also talk of, it's also referred to as man-controlled. Man-controlled, and also we can still refer to it as man-in-the-loop manipulator. Man-in-the-loop manipulator. So we can talk about such type of robot, that is the teleoperated man-in-the-loop, or what we refer to as the man-controlled robot. So when you talk about this particular type of robot, then basically we are simply talking about a robot that it differs generally from the totally machine-controlled robots, and it differs in the sense that the presence of a man is always taken in situations where it is not possible to anticipate all actions and handling requirements. So as we are talking about this, we simply talk about this one is always operated by man. So there will be presence of a man. So there will be some operator that is going to guide it on how to handle certain motions and also anticipate motions and also carry out the required task. Yeah, and also it is also in such operations they usually they're usually servo-driven with master-slave manipulator, and they perform necessary work. That one can be in hazardous environment, taking command from human controller who can manipulate the slave arms at the scene of operation from the location, relying on the viewing from a closed circuit television, that is a CCTV. So in this case, when you talk about the teleoperated, we are simply talking about what a kind of robot that will be guided by a man. So the man will be able to carry out, will be able to operate the particular robot in order to achieve that particular task. And in most cases, this one can be used in hazardous environment, and it takes command. It's mostly from the human controller, who is able to manipulate the manipulator is able to handle the manipulator in order to achieve the goal of the particular robot. The other one, we can also talk about, under still broad classification, we can talk about what we call intelligent robots. Intelligent robots. We can talk about intelligent robots. So when you talk about intelligent robots, then we are simply talking about the very advanced state-of-art robot. And these robots usually have artificial or machine intelligence that is always analogous or the same as the sensory perception of the neuromuscular coordination that the human being is capable of. So they are just made in the same way the human being's brain work. That is what we refer to as the neuromuscular coordination that the human being is capable of, and they are usually used in an environment that can be explorative, maybe in an environment that is explorative, and they can also have they can also be in a position they can also be in a position to evaluate how to carry out a given task. So they can always match the actions of their sensory inputs, and these robots are always very, very advanced, and they can always move over floors, they can climb, they also have the ability to avoid obstacles, they have high power to weight ratios, and also they are also compactly assembled with onboard sensors, and also they have their own power supplies, onboard sensors, the instruments, as well as the power supply. So that is what intelligent robots have. So in this case, we are simply talking about the robots. When you talk of the intelligent robots, we are simply talking about the robots that are able to behave like human, because they have a brain, they have the controller that mimic, or rather is analogous to the human brain, and that one makes them to be in a position to make decisions as far as the control is concerned. So that is the second way by which the robots can be classified. So we are going to the third way by which we can classify the robots. So the third way here is what we refer to as general classification. So the other way is what we refer to as general classification. General classification. So when you talk about the general classification, according to the general methods of classification, the robot can be classified into two, and one of them we can refer to as special purpose robots. So here we have special purpose robots. And then the other one we can refer to it as what we call the general purpose robots. General purpose robots. The general purpose robots. So in this case, when you talk of the special purpose robots, then these ones are robots that are simply designed and produced for a limited range of specific jobs. Like you can have a robot that is produced for specific job like welding, maybe painting, casting, assembling, or even material handling. And these robots that we talk about as the special purpose robots, they usually use the manipulators that have got limited degrees of freedom. They have limited degrees of freedom, and their arms are always activated either hydraulically or pneumatically. The programs of the robot's movement is always recorded in its memory in sequence. So we are simply talking about a robot that is made. So The bottom line is, when you talk about the special purpose robots, then we are simply talking about the robots that are made in order to carry out a specific task. So they usually have a limited range of specific jobs that they can do. As we have said earlier, these ones can be maybe welding, you can also talk of painting, you can also talk of casting, among others, or even material handling. The second under this classification, under the general classification, is the general purpose robots. And these robots are always designed and produced to perform a wide range of tasks or jobs. So they usually, in most cases, you'll find that they may be either servo control or maybe non-servo control, or they may have a sensory type, depending on the sophistication of what it is going to carry out. So those ones are the ways by which we can classify the robots. So you can go further and look at what we refer to as the robot qualities, and generally we can talk of several qualities that a robot should have. So the following qualities will always be expected in the robots. One of the qualities that is very, very important is what we call tactile sensing. Tactile sensing. That is one quality that is very, very key as far as the robots are concerned. So when you talk about the tactile sensing, what comes into our mind is, under sensors, we talked of tactile sensors. So, and we say that tactile sensors are basically contactless sensors. So in this case, we are simply referring to the robots that can have tactile sensing in order to identify an object and perform a function that is based on the referred data. So we talk of the grippers that have been developed, and they are able to pick up any shape of objects, and at the same time not to exert enough force to crush the object. So when you talk of the tactile sensing, we are simply talking about the ability of that particular robot to sense whatever is in the environment, what is there in that particular environment, so that as it carries out its functions, as it carries out its task, it is able to avoid the obstacles, and also when it is also going to handle maybe the object that it is supposed to handle, then it should also handle it gently in such a manner that it is able to pick it up, and it's able to pick up shape, identify where to pick, and also don't use a lot of force in order to ensure that that object is held gently so as not to crush it. Or you can also, you should also ensure that it is not only crushed, but also it is gripped very well so that you avoid slipping or the object from slipping. The other important qualities that a robot can have is, we can talk of the vision systems. Vision systems. The vision systems. So in a robot, you can also always incorporate the vision systems, and the vision systems so that the robot is capable of identifying the part for picking up. So it's supposed to be able to identify the part for picking up, and also it's also be in a position to identify that. And this one can be done by use of the pattern recognition data that is based on the object shape. And such systems can always transform the position and also the orientation of the object into robot coordinates. And this one will always enable the robot to acquire the object in a known manner. So it's supposed to see the object. After seeing the object, know the shape and the orientation of the object, and from there it is able to see how well to hold the object. So there are various types. We can also talk of vision systems that can be used. We can talk of the sensor that may look at the seam that is supposed to be welded and automatically adjust the weld. We can also talk about the vision systems that can recognize the objects. This one can be done by shape and also the orientation. Another quality that we can also talk about in this case, the third quality that we can talk about is the mobility. Mobility. Can talk about mobility. And generally, when you talk about the mobility, generally the robots usually stand in a single position. In a single position or station for the bulk of the factory requirements. However, when it needs to handle intermittent and maybe asynchronous demands, then there is always a need for it to move, and this one will always ensure that there is the mobile, it becomes a mobile device which will be in a position to move in complex paths and access large areas economically. And that one is the mobility. You may find that some robots may be made in such a way that they are standing at one point, but now looking at the arms, and also looking at the arms and the end effector, they can be in a position to move, and that one will enable the particular robot in order to carry out its task. So we are not only talking about, there are some robots that can emulate maybe movement, like you can talk of the human being, you can talk of the rolling robot. So it should be in a position to move so that it is able to achieve the task. There are other important qualities that we can also talk about, and just mention them. Other qualities that we can talk about, we can talk of the general purpose hands as a quality. We can also talk about the ability of the robot to ensure that it interprets the computer using the visual and tactile data. So that one you can say that computer interpretation of visual and tactile data as a quality. We can also talk about the multiple appendage of hand-to-hand coordination. So that is another quality. We can also talk about the man-robot voice communication. So the robots, some robots should be in a position to be able to get communication. And then we can also talk about the inherent safety as another quality of the robot, as well as the interaction with other technologies. In an environment, there will be other technologies in an maybe manufacturing environment, or in the environment where the robot will be. There may be other technologies that have been used, and these technologies will be very, very important. It will be very, very important that this particular robot is able to work with those technologies without interference, and therefore interaction with other technologies is also a quality that a robot should have. Another quality that a robot should have is total self-diagnostic fault tracing. So it is supposed to be in a position to check for, internally check for a fault and maybe trace the fault. So that is all as far as the robot qualities are concerned.